All right, so now we are ready to do the second part of the Excel assignment, numbers 3 through 4. So before you start working in Excel, I want you to go down to the bottom of your Excel worksheet and click the little plus sign to add a new sheet. So you're going to be working in this second worksheet for numbers 3 through 5. So if we go back into the Excel assignment, and now we have a situation where we are going to be looking at a sample of electronic devices instead of just a single electronic device. So now we are talking about the sampling distribution. So now we want to know, what is the probability that Theodore's sample will have a sample mean of 60 seconds or less, and this is a sample mean from 3 electronic devices, even if the software update did not improve download speeds for maps. So now the update has happened. He takes a sample of 3 devices, and he wants to know the probability of getting that desired sample mean of 60 seconds or less, just due to chance, even if the update didn't work. So we're essentially comparing this sample of 3 electronic devices to the original population distribution before the update happened. So let's go ahead and jot down our important bits of information. We've still got our mu equals 90. So mu equals, I just Control C to copy and then go into Excel and do Control V to paste. And we've got 90. And then our standard deviation is equal to 30. And our sample size in this case is equal to 3. And let's go back and look. I think that's all the important little bits of information. We're going to be working with a sample mean of 60 as well. So we want to know the probability that the mean is going to be less than or equal to 60, just due to chance. Okay, it looks a little funky, but I'll know what you were doing. All right, there we go. And then the probability that the sample mean would be less than 60 due to chance, even if the software update didn't work and the devices still represent the original population before the update. So to do this, we're going to have to trick Excel a little bit. I'm going to go ahead and insert some cells here, some rows. So remember when we did the normal distribution function earlier, we had to select the mean and the standard deviation. Well, now we are working with a sample, right? So now our measure of spread is no longer the standard deviation, it's the standard error. So what we need to do is we need to calculate the standard error. And the symbol for that is the sigma with a little x bar below it, but that's complicated in Excel, so I'm just going to put SE equals. Now remember, the formula for the standard error is the population standard deviation divided by the square root of the sample size. So I'm just going to do that within Excel. So equals the population standard deviation divided by squirt, SQRT, that's the square root of the sample size. Close it in a parenthesis and hit enter. And this is the standard error. So on average, just due to random chance, even if I was taking a sample of 3 from the original population, or if I was taking a sample of 3 from the current population, assuming that the download or that the new update had no effect, I would expect that just due to random chance, the mean for my sample would be about 17 seconds away from the mean of my population. So now when we go into here, we are going to say, all right, this is probability less than or equal to 60. So equals norm dot dist. This time x is going to be actually our sample mean, so 60. The mean is still our population mean, and the standard deviation is actually the standard error. And because this is a less than or equal to situation, I am working with cumulative probabilities. So then hit enter. And that is the probability of getting a sample mean of 3 devices with a mean download speed of less than or equal to 60 seconds, just due to chance, even if the update had no effect. All right, so now if we need to figure out the opposite of that, right? So greater than 60, we can just use the complement rule. So equals 1 minus this, right? Everything that's left. So if there's about a 4% chance that it would be less than or equal to 60, there's about a 96% chance that it'll be greater than 60. Now for part C, you can answer this on your own. And let me go ahead and go to Excel. I'm going to go ahead and round these. So right click, format cells, round them to the thousands place, just to make life a little bit easier. And I'll steal both of these. Why not? Control C to copy. Oop. And then go into my assignment. Just paste text only. Control X to cut, and I'll just put that one here. Control V to paste, and let's backspace that out. All right. So I want to bold both of these. And again, you can answer C on your own. So now we get into a situation where we're trying to figure out the confidence interval. So Excel has a really nice function that allows you to do the confidence interval. So I'll show you how to use that. So now we say, okay, let's say that the mean download speed was 60 seconds among these 3 devices after the software update, right? So now we want to estimate, what do we think the true population mean is? Or what range do we think that true population mean of all devices falls into after the software update? We're going to use a 90% confidence interval. So we go into our Excel worksheet, and let's just put in the mean equals 60. We're going to use Excel to find the error for a confidence interval of 90%. And then what we're going to do is we're going to take that mean and we're going to take the error associated with the confidence interval, which is E in the formula, which is basically the z-score times the standard error, but Excel will just give that to you. So we're going to take the low end and the high end, and I'll show you what that looks like here in just a sec. So again, mean download speed of 60. We're still working with the same scenario where that mean came from a sample size of 30, and we're trying to figure out what we think, where we think the new true population mean falls. So we can go equals confidence norm. See, returns the confidence interval. So we just double click that. Now remember, if your alpha level is the inverse of your confidence interval or your confidence level, right? So if we have a 90% confidence level, then what's left? Well, 10%, right, to get us up to 100%. So if you have a 90% confidence interval or confidence level, your alpha is 0.10. If we were doing a 95% confidence interval, then the alpha would be 0.05. 99% confidence interval, alpha would be 0.01. So because we're looking at a 90% confidence interval, this is 0.10. Our standard deviation, use the actual standard deviation, not the standard error. And then the sample size. These two pieces of information will allow Excel to calculate the standard error kind of in its own little awesome brain. So then hit enter. Now this tells us the margin of error. This tells us kind of the spread of our interval. So now that we have our kind of margin of error, the spread of our estimate, we're going to find the low end by going equals the mean for our sample, that's our reference point, minus the margin of error, equals, and then equals the mean for our sample plus the margin of error. And this is the range that we're working with. So I'm just going to hit Control C to copy. And if you get funky numbers, like if you get something really large, you can just go to Format Cells and you can have it round to 3 decimal places under number. So I'm just going to copy this, go into my assignment, arrow below paste, paste text only. So our confidence interval is 31.510 to 88.90 seconds. So now I want you to take a look at that and think about what that suggests about the new download speed among all devices. So based on this sample, actually from 3 devices being 60 seconds, do you think that in the population that the download speed has decreased from the original download speed? And if so, how much do you think it's decreased by? So one way to think about it is that 90 captured here? Well, if not, we can be 90% confident that the true download speed in the population actually has decreased from 90. It may or may not be at 60, but at least we know it's decreased from 90. So now I want you to take a stab at number 5 on your own using what I just showed you. And just to show you, you're going to be doing a 90% confidence interval again, so alpha is still 0.10, but now you're working with a situation where the mean is equal to 75. So let's say that Theodore took a sample mean from 3 devices, and now it's 75 seconds. So now you need to find a new confidence interval using 75 as a frame of reference, and then if that was the case, what would that suggest about the new download speed among all devices? So I hope you found this useful and maybe a little easier than using those unit normal tables.